Periodicity. All elements within a period have the same number of electron shells. All the elements within a period have the same number of electron shells. All the elements within a group have the same number of electrons in the outer shells. All elements within a period have the same number of electron shells. All elements within a group have the same number of electrons in the outer shell. Therefore, similar properties. What does the group number tell you? The number of electrons in the outer shell. The exception is group 0. So does it have 0 electrons outer shell? No. This group 0 elements have full outer shells. Why does atomic radius decrease across a period? The number of protons increases, therefore the positive charge of the nucleus increases. Electrons are being pulled closer to the nucleus as increasing positive charge of the nucleus. Therefore, atomic radius is smaller. Electrons are becoming closer to the nucleus, atomic radius is smaller. Just because the number of protons is increasing, positive charge of the nucleus is increasing. However, extra electrons elements gain across a period are added to the outer energy level, so it might be like shielding. However, there's no extra shielding effect because remember, shielding is caused by electrons in inner shells. Shielding caused by electrons in inner shells. These extra electrons elements gained across a period are added to outer energy levels in the outer energy level. You add it to the outer energy level. If it's in energy level, then yeah, shielding will be caused. But outer energy level, so no extra shielding effect. Melting points across period 3. You can see here a lot of peaks and dips and all of that. Periodicity, the regular recurrence of the regular recurrence of the properties of elements when they are arranged in atomic number as in the periodic table. The regular recurrence of the properties of elements when they are arranged in atomic number as in the periodic table. Sodium, magnesium, aluminium, metals, all metals. The melting point and boiling point increases across the period as metal-metal bonds get stronger. Metal ions have an increasing positive charge, increasing number of delocalized electrons, and a decreasing radius. Why is magnesium described as an S block element? Highest energy subshell is an S subshell. Now, the reason I included this because I could definitely see this being asked as a question in the exam. It's not asking about any of this knowledge, it's saying why is something as an S block element, or you could say why is something as a D block element. You just need to say the highest energy subshell is a S subshell, highest energy subshell is a D subshell, whatever the question says. Just change it to whatever the question says, and definitely one marker, highest energy subshell is an S subshell. Silicon, macromolecular with a tetrahedral structure, strong covalent bonds which links all the atoms together, requires a lot of energy to overcome the bonds. Phosphorus, sulfur and chlorine, P4S8Cl2, molecular substances. Therefore, the melting points depend on the strength of van der Waals forces between molecules. Van der Waals forces are weak and easily overcome, therefore low melting points. However, more atoms a molecule means stronger van der Waals forces, so therefore the biggest molecule, sulfur S8, has a higher melting point than phosphorus and chlorine. Why does ionization energy increase across a period? Increasing attraction between outer shell electrons and nucleus as the number of protons increasing. Increasing attraction between outer shell electrons and nucleus increasing attraction between outer shell electrons and nucleus as the number of protons increasing. Periods, horizontal rows of elements that show trends in physical and chemical properties across the period. Groups, vertical columns of elements that have similar physical and chemical properties. Periods, horizontal rows of elements that show trends in physical and chemical properties across the period. Groups, vertical columns of elements that have similar physical and chemical properties. And remember, periodicity, regular recurrence of properties of elements when they're arranged in atomic number as in the periodic table. Oh yeah, and argon. Argon has a very, very low melting point as it exists as individual atoms. Argon is monatomic, therefore weak van der Waals forces between molecules. It exists as individual atoms.